Hello, this is Mr. Bradsby. Today we're going to be working on some graphs. Graphs are a way of displaying information. You'll see graphs on the news and in the papers and online where they're trying to show information about things that have happened. In this case, if you'll notice what we call a title here, this is the title, and it says hats worn to school. This would be like in January when it's cold, a lot of the students wear hats to school. And so what we have here is Jimmy, who's represented with a J, Brian, who's represented with a B, Suki, who's represented with an S, and Mariah, who is represented with an M, the first initial of their names. And so here's information about hats worn to school. Okay? These circles represent hats. So each circle represents hat. But if you notice down here at the bottom, here is what a hat value is. And so here's the code saying that a hat is 3 days. So each hat represents 3 days that they wore a hat. Okay? So that's what this graph is all about. And you can look at the graph and see lots of information. And so I'm going to ask you to figure out this information. So let's say that these are hats worn to school in January. Jimmy, how many days did Jimmy wear a hat? How many days did Brian wear a hat? How many days did Suki wear a hat? How many days did Mariah wear a hat? Okay? Well, I'm going to do a simple one here. I'm going to do Brian. Now, if you look at Brian, okay, here's Brian again. Brian B has 3 hats there. But each hat represents 3 days, right? So if we count these, there's 3, that's 6, and 3 more is 9. So Brian wore a hat for 9 days. Okay, I'm going to put you on pause, and I would like you to determine the number of days that Jimmy wore a hat, that Suki wore a hat, and Mariah wore a hat, just like I did with Brian. Okay, so please put me on pause and determine the number of days that each of these students wore a hat. Okay, we can continue then. I wrote down what I think is correct. In fact, they are. Jimmy, 1, 2, 3, 4, 5, 6 hats, each 3 days would be 18 days. Suki has 1, 2, 3, 4, 5, 6, 7, 8 hats there. 8 hats, each one 3 days, so that would be 24 days she wore a hat. Okay, she has the most, doesn't she? See the information? You just look at the graph and see that Suki wore the hat more than anybody else, and Brian wore the least number of hats. Well, and Mariah has 4 or 12 days. So those are the days that each of these wore hats. And when you make a pictograph, what they're doing, or when you read a pictograph, they're trying to display this information for you. How many, which we did over here, this is how many each wore, which had the most, which had the least, and so on. Okay? So hopefully this helps you interpret the graph. here is what it shows, really. And rather than writing this out in an article, they make a graph. It's a nice way to picture the information. So this is a picture of what this information over here represents, the graph. Okay? Well, then we could find lots of information about the people here and what they did during this cold spell and when they wore their hats or didn't wear their hats. Okay, so here's another question that we could, or another thing we could do with the graph, and that's look at the relationships, the comparisons between people in the graph. For example, let's write an equation using addition and one for subtraction for the number of hats worn for Brian, use B, and Mariah, we use M. So let's see, can you write an equation that relates the Brian and M, Mariah, B and M, write an equation using addition and subtraction. And there's no just one way to do it. There's a lot of ways to do it. So think about this, put me on pause, and try to write an equation using addition and subtraction that compares Brian and Mariah. I hope that's clear, but put me on pause and write an equation for addition and write an equation for subtraction. And when you get that done, turn me back on and I'll show you some of them that I wrote, okay? But you do it first. Try it out and see if you can do it. Okay, so here we go. Here are some of the equations I wrote using addition and subtraction for Brian and Mariah. Maybe I wasn't clear, but I wanted you to use what we call, as you know, variables, both the B and the M when we write these out. But this gives you an idea of what we could do. We take Brian, who has 9, okay, and Mariah, who had 12. Well, Brian, 9 plus the 12, the days they wore hats, 9 plus 12 is 21. So Brian plus Mariah was 21 days they wore hats. Another way would say Brian, who had 9, 9 plus 3, Brian plus 3 equals the 12 that Mariah had. So there's a couple addition sentences that show that Mariah had more because they had to add 3, but together they had 21. Okay, there we go. So that's addition, using the B and the M, the Brian and the Mariah, And then here's some subtraction that I wrote. Mariah, which is 12, subtract 3 gives us the 9, which was what Brian had. So M minus 3 is B. Or, from this sentence here, we could do the inverse operations. Okay? If Brian plus Maria is 21, 21 minus Brian gives us Maria. 21 minus 9 is 12. And the other, because there's two ways to write these, remember? 21 minus Mariah is Brian. 21 minus 12 is 9. So those are inverse operation sentences, these, for the Brian plus Maria is 21. So there's some addition sentences to show the relationship, and here's some subtraction. You may have wrote something different, and if you want to ask your teacher later if this was acceptable as a good way to write it, that's fine. But I just wanted you to show you some ways that I see these relationships. Okay, so there we used addition and subtraction to write some comparison problems for Mariah and Brian. Now let's look at, could we write some equations for multiplication and division for Jimmy and Brian? So again, we're going to use Brian, but we're going to take Jimmy, that's here, right, and Brian, and see if you could write an equation using the J and the B, right? Okay, using Jimmy and Brian, relationship between them, and see if you could write a multiplication. You only need to write one. I wrote several, but you only need to write one for multiplication and one for division. And again, there are probably many ways that we could do it, but we're going to stick with write one for Jimmy and Brian together, one for multiplication and one for division. Please put me on pause and write these equations. When you're finished, we'll continue with the lesson. Well, with the multiplication and division, there aren't as many options. The way I saw it then is that Brian, who has 9, and Jimmy has 18. So, and even if you look at the pictures, you'll see here that Jimmy has twice as many hats as Brian. In other words, you multiply Brian by 2 and you'll get Jimmy right here. 2 times B, 2 times 9 is 18, which is what Jimmy has. Go over here to the numbers. Here's the 9, here's the 18. What's the relationship? Well, 2 times 9 is 18. Well, then you go to the inverse operation. Jimmy, which is the 18, divided by 2 gives us Brian. So Brian has half as many. That's what this says. J divided by 2 has half as many as Brian. And so there's a multiplication and a division problem. We could also ask, how many more books did Jimmy have than Mariah? How many more did Suki have than Jimmy? So we could do things like that. Or those are the type of questions you could ask off this graph, and we could find the answer to those. So the picture tells you a lot. A lot of times, like we did here, Jimmy and Brian, we can see that Jimmy has twice as many. The relationship in multiplication is twice as many. Just like we did with the bars, the comparison bars, here we can compare the figures, right? Here, compared to this one down here, there's 3, takes 3 more to make it. So what was missing over here? So you can compare the pictures and get answers in a picture graph, pictorial graph. Okay, so that's good. I think your teachers may have some other pictographs that they want to work with you with. And I'm going to go ahead, though, and look at a bar graph. All right, so here we have a bar graph. Bar graphs are used, again, to show information and picture it. So this is a picture of some information. Well, let's try to understand what the graph says. Up here at the top is the title, and it says snow days. So I guess it is the number of days that it snowed. And we look down here at the bottom, and the scale, these are months of the year, months. So, and that makes sense because here's December, January, February, and March. So in Colorado, we have it snowing a lot during these months. But this year, you never know. So we look at what it says, the number of days they had measurable snow. That's what this graph is all about. So December is represented in the green here, and January in the yellow, February in the blue, and March again in a green color. Okay, so that's it, and we need to figure out what this is. The snow days that we had, the days that it snowed in December, January, February, and March of this year, with whatever year this is. So this is the representation. And weathermen collect this type of data. They want to know what happens, and they can compare and what months. If you wanted to, you could build another graph of what happens on the average and compare these and see. So this is a lot of information, though, what we had for snow days, the number of days that it snowed. So what I'd like you to do is see if you understand this graph, first by putting down the number of days for each of the months. In other words, how many days did it snow in December? How many days did it snow in January? How many days did it snow in February? And how many days did it snow in March? Okay? So put me on pause and read the graph and tell me from the graph how many days it snowed for each of these months. Then when you're through, come back and we'll do some more. All right, well, from the graph, I can see that December it snowed 4 days, and January it snowed 2 days, and February was 6 days, and March was 8 days. So that's the number of days from the graph that it snowed. And March had the most, January had the least, right? You could see that on the graph. See that from the picture? And the others were, December and February were in the middle of those, but the most snow was in March that year. All right, well, let's do the same thing we did with the pictorial graph here, and let's look at, is there an equation that we could write using addition and subtraction for December and January? So if we go to December and January here, is there an equation we could write using the D and the J, the variables, to show an addition and subtraction, one for addition, one for subtraction, sentence for December and January? Okay, we're going to add for one equation, and we're going to subtract for the other equation. Addition and subtraction using December and January. And you can look at the numbers up here or look at the graph, because there's a picture there. It'll show you what the relationship is. Okay, put me on pause and come back and we'll see what I could write down. All right, I ask you to write one for addition and one for subtraction. Again, there's multiple ways you could do it, but what I said was that December, which was 4, plus January, which was 2, is 6. 4 and 2 is 6. So that's an addition sentence using the variables D and J. So there was, in December and January, there was a total of 6 days that it snowed. Also, January plus 2 is December. In other words, January had 2 days of snow and 2 more days of snow, so it was equal to December, 2 more days of snow. The subtraction, then, I'm going to do the inverse operation of the D plus J equals 6, so 6 minus D must be J, and 6 minus J must be D. And again, you could write them the other way around. J equals 6 minus D, D equals 6 minus J. And we know that's the same thing from what we did before. Another one is December, which had 4 inches, minus 2 is equal to January. It's 2 days less. And so that's what this says, 2 days less than December. Okay, so there's an example. Now we could try and look at some more information from the graph. Which month, for example, had 4 times as much snow as January? Okay? Which month had 4 times as much snow as January? You can look at your graph, you can look at your numbers and try to figure it out. So 4 times January is what month? You see, that's a multiplication here. How many times, and when you say how many times, you're usually looking for a multiplication. Multiply it, get a multiple. So look at the graph and tell me which one had 4 times. Well, that was March. Okay? So that's another example of information we can look at. It was really snowy in March compared to January. 4 times as much snow in March. That's what this means. 4 times as much as January we had in March. So lots of information there, lots of things you can do, but this is a bar graph. And you'll see a lot of bar graphs in data when they're presenting them, again, on news shows or in newspapers or in magazines where they're trying to, whenever they're trying to picture data, you can use a bar graph. So this is 2 ways of displaying data. I think your teachers can answer any questions you might have. If we went too fast, they have some examples in your book that you can discuss and maybe some problems that they could do with them. Thank you for listening.